Okay, properties of quadratics. This is a quadratic function, and it's actually written in what's called factored form. So I'm going to write the parent function, f of x, the parent function of factored form. Again, there's an a value in front of this, and we have an x minus, yes. And technically you can use any letters, R, S. We tend not to use, and I'm going to quickly write them out here, they tend not to use these letters, an A in there, an H, a K, a B, or a C. And the main reason is because those are all involved in like standard form or vertex form. But really any letter, they're just representing an unknown number, right? And in fact, what they help us represent is what the x values are. Because this is, they call us factor form, but factor form helps us find the zeros, or not the vertex, the roots. That's the word I'm looking for. Thank you. So because they've given us that, we're going to do kind of some rough sketching on the side here. First of all, let's take a look what our values are. A is a positive value, okay? So we talked about this before. If A is positive, we're smiling, it's going up, and if A is negative, it's frowning, it's going down. So we know it's going to open upwards. Our actual vertex is going to be these two values here. Now the y is going to be 0 in both of the cases, so I'm going to write the first vertex and the second one, and technically the y value is 0 in both of these because it lies along the x-axis, okay? So here's a negative, positive, positive, and negative of our graph. Because this is negative 2, and because there's a negative in this function, in the parent function, we actually flip it. So the one vertex is going to be 2, and the other one is going to be negative 10. Wonderful. So 2, that's about here. Negative 10 is probably somewhere along here. This is just a rough sketch. It's not perfectly accurate. We know that it's going to look something like this because it's opening upwards. It's going to go down, come up, do. One of the key things it's going to ask us is where's the vertex, okay? Now our function doesn't tell us where the vertex is, so we have to use a bit of a formula. In fact, we can use a formula that helps us with the axis of symmetry. So AOS is equal to, they call it x1 plus x2 divided by 2. And really what it is you're just finding the average between these two, because that's going to be the exact middle of the parabola. So we add 2 together, divide by 2, that's exactly how you find the average of something. So we put them together. We're going to have 2, which is one of the vertices, and the other is negative 10. So 2 minus 10 over 2. That's going to give us negative 8 divide 2, which is going to give us negative 4. Wonderful. So we found the axis of symmetry. We'll say that's about negative 4. Okay. It's a little crooked what I've drawn. But there's our axis of symmetry. That is also the x value of the vertex. We have the y value of vertex too. So we know that the x value is negative 4. The only thing left is to find out what the y value is going to be. There's a couple ways we could do it. One of the simplest from the information we have right now is to actually just take this value and plug it into the two x values and find out what the function will be equal to. In other words, what the y value is. Let's see if I have a little room for that. I might have to shrink this down a little. Ooh, that didn't work out, so I'm going to write it on the side here. We'll do it in black on the left bottom corner. So the function, when x is negative 4, is equal to 3. And I'll write that in red. Negative 4. So equals x. Oops, not x. I apologize. Negative. Yes, thank you. Negative 4 minus 2. And negative 4. Well, we're going into the other one. Okay, we'll try to simplify this. The 3 will stay. Inside our brackets, negative 4 minus 2 is negative 6. Negative 4 plus 10 will be positive 6. That's going to be negative 36 times 3, 112. We better get a calculator for this one. I'll do it on the side. 36, hello, there you go. By 3, 18, 9, 108. Okay, I was way off. Negative 108. Wonderful. So the y value of the vertex is negative 108. So clearly we're not nearly low enough on our sketch here. It should be negative 108. But you get the idea, especially because the wider apart your two vertices are, more likely the farther down or up, depending which way it opens, the y value of the vertex is. Let's go through our checklist here. So we got the direction of the opening, we got the vertex, we got the axis symmetry. we got a graph, but we don't have a domain and range. We talked about before how our domain is x such that x is the element of all real numbers. Essentially, parabolas, they go left and right forever. Do you remember what it's going to be for our y? Y is the element.
Real numbers, and y is greater than or equal to -108.
Perfect. And it's greater than and equal to because it opens upward. Had it opened downwards from there, it would have gone the other way. Exactly. Let's draw this in decimals to make sure it works. So 3, -2, and +10. This was our graph from before, but y is equal to 3 bracket x minus 2 in bracket x plus 10, I believe. Here we go. So we're going to have to zoom out a little. Ooh, really far. Can we get our vertices? Here we go. There we go. 2 and -10, we were right. And -4 and -108. Exactly what we predicted. See if it'll do them all. Yay. Okay, great. So we did that properly.